Good day everyone, this is Sir Albert. In this next series of videos, we're going to take a look at how you add or subtract dissimilar rational expressions. Before we discuss this, we take a look at first how you add or subtract dissimilar ordinary fractions. When we speak of dissimilar fractions, these are fractions with different denominators. In adding or subtracting dissimilar fractions, we first find the least common denominator, or the LCD of the fractions. Consider the example 1/2 plus 2/5. Take note that 1/2 and 2/5 are considered as dissimilar fractions because their denominators, namely 2 and 5, are different. To add these fractions, we think of the least common denominator of 2 and 5. To do that, we think of the smallest number that can be divided both by 2 and 5. That number is going to be 10. So we say that the LCD is equal to 10. We can double check that 10 divided by 2 is an exact number, and 10 divided by 5 is also an exact number. So we say that 10 is the smallest number that can be divided by both 2 and 5. Once we have the LCD, the next step is to multiply each fraction by an expression equal to 1 to produce an equivalent fraction that uses the LCD. We consider first the first fraction of 1/2, and we multiply this by an expression equal to 1 that would produce a similar fraction that makes use of the LCD. If you notice, with the denominator of 2, we need to multiply it by 5 so that we end up with a fraction that has a denominator of 10, which is the same as the LCD. If we're going to multiply the denominator by 5, then we should also multiply the numerator by 5. Here, 5 over 5 is the expression equal to 1 that would convert our original fraction to a similar fraction that uses the LCD. Multiplying now the numerators 1 and 5, we get 5 over 10. Notice that 1/2 and 5/10 and 5/10 are equivalent fractions. Next, we consider the second fraction of 2/5. Just as we did with the first fraction, we think of an expression equal to 1 that we're going to multiply 2/5 with so that it would end up with a similar fraction that uses the LCD. With a denominator of 5, we would need to multiply this by 2 so that we would end up with a fraction that uses the LCD of 10. Multiplying the denominator by 2, then that means that we also have to multiply the numerator by 2. Notice that 2 over 2, it's a fraction that's equal to 1, and this is our expression equal to 1 that would convert 2/5 to its equivalent fraction of 4 over 10. Note now that with 5/10 and 4/10, we are now going to work with similar fractions. So the next step is that once the fractions have the same denominator, then we proceed with adding or subtracting similar fractions. That is, we simply operate with the numerators, so we would get 5 plus 4 over, copy the common denominator of 10. 5 plus 4 would give us 9. Copy the denominator of 10. This is already a fraction in simplified form. So 1/2 plus 2/5, the final answer is equal to 9 over 10. This is going to be our final answer. In adding or subtracting dissimilar rational expressions, we make use of the steps similar to the previous example. Those are, first, find the LCD of the rational expressions. Then, change to similar rational expressions by multiplying each rational expression by an expression equal to 1 that uses the LCD. And finally, once the rational expressions have the same denominator, we then proceed with adding or subtracting similar rational expressions. To illustrate these steps, let's take a look at the first example, which is 7 over 6xy squared plus 2 over 15x squared y. The first step is to find the LCD. So, to find the LCD, we consider first the numbers 6 and 15. We think of the smallest number that can be divided both by 6 and 15, and that would be the number 30. Double check, 30 divided by 6 is an exact number, and 30 divided by 15 is also an exact number. So we say then that the least common denominator between 6 and 15 is 30. We consider now the other factors. We see that both denominators have a factor of x. So we take the factor x, and as always, we take the highest exponent. Between x to the first and x squared, the higher exponent is x squared. So x squared is going to be part of our LCD. Y is also a factor that's common to both denominators. So we take y and we take the higher exponent, which is 2. Therefore, our LCD for 6xy squared and 15x squared y is 30x squared y squared. Second step is to change to similar rational expressions. Given that the first rational expression is 7 over 6xy squared, we multiply this by an expression equal to 1, which would convert this to a similar fraction, which uses the LCD. If we have the denominator of 6xy squared, then we need to multiply this by 5x, so that our resulting fraction would make use of the denominator of 30x squared y squared, which is the same as the LCD. Multiplying the denominator by 5x means that we also have to multiply the numerator by 5x. This will then give us the equivalent rational expression of 35x over 30x squared y squared. Working on the second rational expression now of 2 over 15x squared y, we multiply this by 2y so that we would end up with an equivalent rational expression with a denominator of 30x squared y squared, which is exactly what our LCD is. So multiplying also the numerator by 2y, we would end up with 2 times 2y or 4y. The given expression now is equivalent to this new expression. And we would see here that the resulting expression is now similar rational expressions. So third step is then to proceed with addition or subtraction of similar rational expressions. This means that we operate with the numerators and copy the common denominator. Working on the numerators now, this would give us 35x plus 4y all over the common denominator of 30x squared y squared. This is now going to be the simplified form. Just finish off with a restriction. Take a look at your denominators. Your denominators make use of the variables x and y, and we don't want these variables to be equal to 0, because otherwise we would end up with an undefined fraction. So we say that the restriction is xy such that xy is not equal to 0. Here then is our final answer. Work on exercise 7.05 found in Schoology. Take note that these items were taken from your textbook.